First of all, first of all, thank you for being here. And I know what might be going on in your mind. Another AI trend that we don't want to put in an area, right? So firstly, let's embrace AI is not going anywhere. AI is going to stay. So instead of being, instead of moving it away as a security community, I feel we should embrace it to see where we can use AI. And instead of just throwing random stuff in it and ask you to do an entire security engineer work, which I'm sure there might be a marketing stuff, but if you give it a precise instructions and a precise task to do, I'm sure that we can achieve results. And that's where we're going to talk about. So we would be talking about continuous threat modeling, which as a security community, we face a lot of challenges in how do we update our threat models to stay relevant to the latest changes. So how do we achieve continuous threat modeling using large language models? So that's why I've specifically went instead of AI, I went in LLM so that it might just sound a different topic, but we would be using LLMs. So who are we? We are a duo of DevSecOps and DevOps engineer working at Glassful Solutions, and we are passionate about security, AI, and any new other ideas. Before we start talking about uses of LLMs into threat modeling, let's first start understanding what is threat modeling. If we look at threat modeling at its core, what is it? It's a structured approach to identify threats, assess them, propose mitigations, and act on remediation. It's simple. What can go wrong is this entire threat modeling. And how do you do this threat modeling? First, you understand the potential threats. You devise countermeasures and you assess those measures. And there are certain key frameworks which you can use to threat model like Stride, Pasta, Linden, etc. And these all has its own unique approach. So if we think of any threat modeling, so how do we start? We start with 4 basic questions. So this is an excellent book that if you are interested in threat modeling, you should read it. But we should start asking 4 questions. What are we building? What can go wrong? And what should we do about the things that can go wrong? And finally, how do you ensure that whatever you have implemented is doing a decent job of protecting stuff, right? So let's understand this with an example. For example, consider an example of what are we building? A login page for an e-commerce application. What can go wrong? Login page can be bypassed, or someone can brute force the credentials, or someone can perform injection attacks. And now, what are we going to do about it? We're going to validate it. We're going to implement account lockouts. We're going to implement a lot of security controls. And how do we ensure? We ensure by doing, let's say, security review, code review, pen testing, all that stuff. So this is how you approach, as in we approach a generic threat modeling. And now let's look at a traditional threat modeling. When I say traditional, the current state in which as a security team, how is this being handled? So it pretty much flows into this way where first the requirements are discussed and then a design is created. Then a meeting is set up with security teams wherein you discuss threat model and then a lot of inputs from security team. And then you come up with countermeasures which are integrated into design. And then it goes into development phase where the things are development. If you see, there's a challenge here. It's a one-time process just after design. Once it goes into development, there are certain challenges. If you look at, it's only performed once at the beginning of SDLC. And during implementation, there can be a change in the design or a deviation from design, which is not accounted in threat model because threat model only looked at the design, not in the implementation. And there is no continuous feedback loop between developers and these potential security threats. So it is away from the development phase or the phase where development actually happens. In some cases, the threats that were discussed in design phase might not end up during implementation. So what we're going to do? We want to bring threat modeling closer to SDLC. So when we say closer to SDLC, work where work happens. We want to do the threat model and to act on the threat model closer to the development teams. And the first or closest to the development teams is at the code. And the second way is work items. This is where you're going to have a lot of information about what is the implementation look like. So what we propose? We are proposing a new field in user story, which can capture the threat model, which is very specific to that particular user story. So instead of being at a high level, we'll drill down and we look at threat model at an individual user story basis. So this way we provide a continuous feedback loop, but there's a problem with that. The capacity of and time of security teams is very limited. So a member of security team cannot be in each and every user story and then come up with threats. So that's where we bring in LLM. So now I would like to invite my co-speaker, Pranay, to take over this.
Thanks, Gurunatha. So far we have seen the challenges in the traditional threat modeling. So now let's see how LLMs can address these challenges. So to begin with, so the idea is to, every time we create a story, a user story is created. So we send the content of the user story to the LLM and then let the LLM do the threat modeling, and the output of the LLM should be updated in the user story. So let's see how that is implemented. So the first step is when typically product managers or product owners, when they create a user story, they enter details of in the user story. So things like what they need to, what the developer needs to do as part of the story and what is expected as the output of the story. And that goes into the description or acceptance criteria and things like that. And when that work item is created, we need to send a notification to a web API server so that we developed. Which is listening for the events, and that event could be in the form of webhooks. So the API server accepts that API calls, and that API call body contains, let's say, a JSON with the content of the user story. It can contain the title, the description of the user story, and the project it belongs to, and the overall features, parent feature it belongs to, and all these details are then passed by the API server. And now we have the content of the user story. Now we can send that information to LLM for threat modeling. So that's why we send the content of the user story to the threat modeling. So that's good. But the threat modeling, so the LLM needs to know more about the user story. So which app it belongs to, or which product it belongs to. So is it an e-commerce application, or is it a banking app, or something else? So it needs the app context, so that it can do the threat modeling better. So that's where we need the app context. So based on the project name or the feature or the epic name, so we can get the app context and send it to the LLM as another input. Along with that, the LLM works best when we ask what we need out of it. So we can give the threat modeling strategies that we need from the LLM. So there are a variety of threat modeling strategies. So we give that, and sometimes the user stories may contain existing threat modeling output. So the previously identified threats can be present on the user story. So if we give that as an input to the LLM, so that works even better so it knows better that these are the variety of threats that can be possible in such kind of user stories. So we send that previously identified threats, and combining all this information with a refined system prompt, when we give the information to the LLM, so it gives the output in the form of possible threats, and that threat information is now updated in the work items directly. So as soon as the work item is created by someone, behind the scenes everything happens, and the possible threats are updated in the user story. So that creates a continuous feedback loop, and this happens for every user story. Along with that, we update the content of the threads in the database as well. So this is useful to build the threads that were identified over the time, and we can use that existing threads in the future iterations when the same work item is processed multiple times. Okay, so now that we understand the solution, let's dive into, let's see it in action. So this is let's assume that a startup company wants to create an application called Spendwise. It's a typical expense management tool. So we are creating a user story, and it is to basically create reports and upload invoices. So this one is to attach receipts to the user story. So we enter the title, enter the description, and then click the save button. So as soon as we did that, the webhook API is called and a request has been sent. And now behind the scenes, the server and is talking to the LLM, and the LLM gave the response, and it automatically updated the AI security checklist there. You can see that. Okay, so let me pause here. So for uploading the files or the invoices to the expense report, it gave 3 items in the security checklist. So one is insecure file uploads. So it's possible that a person can upload a malicious file, and that needs to be addressed. The file should be sanitized. And the broken access control is another issue. So one person should not be able to upload or override or access other person's invoices. So it needs to be addressed. And the data leakage. So the monitoring and logging should be set up correctly. So all these are given by the LLM, and then the developers can easily address those issues in the implementation phase. So moving on. So now these are the basic concept, and this has a lot of potential. So these are the few of the ways where we can extend this, and so let's go through them. Sorry. Okay, so one of the ways to improve the efficiency of the LLM. So we can give as much relevant information as possible. So one is the application context. So the product documentation, it can be in the form of the design sessions or the transcripts of the design sessions, and or the video tutorials and the company information. So if we give more and more relevant information, the LLM can give better output. And another way is to improve the prompts. Prompt refinement. So we can fine tune it to as per our needs. So and we can ask LLM what we need in the prompts. And another way is to use specialized cybersecurity models rather than using generic LLMs. And another way is to fine tuning the models. It can be company specific, and it can be pre-trained with company data or the security data, and things like that. And finally, so while we have these threads from the LLM in the user stories, those user stories can be further refined by security teams and the development teams during the refinement sessions. Okay, so moving on. So this is all good. So it's a great idea. So, but this also has some limitations. So let's talk about some limitations. So the first one is not really a limitation. So this idea is not to replace the traditional threat modeling, but it is to augment the security teams. So the main limitation is the model being a black box. So LLMs are developed by some different companies, and we really don't know how the LLMs work and how a given output is given by the LLM. So that's one. And the model being non-deterministic. So example, so every time a given input is given, so the model might not give the same output. So that's one. And data privacy is another concern. So the user stories may contain sensitive information about the product lines and things like that. So we need to keep in mind when we are using cloud-based LLMs. So one way to mitigate that is using self-hosted LLMs. And because of these reasons, the teams might not have full confidence on these AI systems as we are still evolving. So that's something to note about. And the LLM most of the time can it can give a variety of threats based on the theoretical knowledge. So we need to prioritize the practical ones and above the theoretical ones. So that's another one. And finally, the LLMs, when integrated with the project management tools, depending on the company size, the price of the usage of the LLM can scale with the usage of the LLM. So the price can go up. So these are the limitations, and that's about it. these are some of the links if you want to read further.
Yeah. Thank you.
Sure.
Finally, thanks to Grant for being a mentor, for reviewing this multiple times and providing his inputs. Thanks, Grant. And finally, Besides London. If I may take another 30 seconds. So I was at Besides London last year as a participant, and I saw the environment and really liked it. And then I thought that I should be part of it. So then I signed up for volunteer, and then I did volunteering at Besides Leeds. And then I should sincerely thank Besides for being the warm, that community for welcoming and also providing. So even just before starting this talk, I was texting the previous mentor, and then he was like, you are going to do that. So that's why, like, if you get a chance, try to just be involved with the Besides community. A big thank you for the entire Besides community and the crew there. Thank you. Thanks everyone.
Thank you so much.
Thank you firstly for the talk. Really interesting topic. I just wondered if you'd given any thought to using the LLM to create the code in the first place. So you're having a full stack approach and you're actually qualifying the code before it's coded in an essence, rather than reactively assuming the vulnerabilities in the code from a human perspective. And also within that, had you given any thought into federated learning in terms of ensuring the consistency of the language model training data?
Yeah, firstly, we believe that LLM cannot be just let it loose on performing just writing code on its own. So we feel that there should be a security or a developer in the middle. And yeah, as you mentioned, LLM can write security code based on, or can write code based on the user story, and also can review this code that is present based on the code. So that comes in the implementation. And what we want to address is making sure that developers are aware of these risks so that they can have the right controls implemented during the code. So yeah, developers can use these LLMs to address these security threats. That comes into a different phase. And this, we want to increase the awareness of developers. Yeah. Thank you. I'm sure in the interest of time, but we are here. If you have any questions, we would love to discuss. Thank you.